Good afternoon from the Bayer Learning Center at Gothenburg, Nebraska. I'm Mark Ryman, Learning Center agronomist, and today I wanted to take time to go through a study we did last year on corn relative maturities and their response to delayed planting. So I know we're not really thinking about delayed planting right now, we're thinking about getting into the field, but the weather conditions this morning were kind of a reminder that Mother Nature really holds the key to that. It was 16 degrees. We had about an inch of snow on the ground, and we're only 5 to 10 days away from planting, so I really hope it warms up. In 2019, of course, we had a large challenge with a lot of rain. It was tough to get strip till done, and a lot of the field operations we needed to do ahead of planting, so planting got behind, and then through planting we fought a lot of mud. Everyone seemed to be doing this, and we got a lot of questions about, in relation to relative maturity, and do I need to be switching it? If I'm planting at this time, what product should I be planting? And so there's a lot of need for information on, what happens if I plant X relative maturity of corn, say in mid-June. So the late planting gave us an opportunity to try that. We know that there needs to be a better understanding of the response of individual corn products to late planting relative to the number of growing degree units required to reach silking and black layer. And there's a lot of university publications that indicate that planting corn late indicates that it's going to take fewer GDUs to finish. So for some reason, planting late seems to speed up the physiological maturity of corn in relation to GDU accumulation. And that could lead you to the ability to plant a later relative maturity than you think based on your calculation of GDU accumulation. And this trial was really set up to measure product performance in terms of yield, and then what the impact on grain quality was of having an early frost on some of the products. And we really wanted to understand what's going to be the best one for your farm when we plant in mid-June. So the study was a randomized complete block with 3 replications. The rows were 130 foot long by 10 foot wide, and we harvested the center 2 for data. And it really was just set up as rep 1, rep 2, and rep 3 in strip blocks. The treatments consisted of 7 corn products with a wide range of maturities, and we went from 76 RM that you might see in North Dakota to 86, 96, 101, 106, 111, and 116 RM products. We did plant these on soybean ground. It was strip tilled in preparation for planting. We have a silt loam soil here at Gothenburg, and we planted them at 34,000 seeds per acre. When we look at what happened through the growing season, you really have to go back to, GDU accumulation. So the 2019 GDU accumulation from the 17th of June to the 1st of September was really right on average. The red line is 2019 accumulation. The green line is our average accumulation, and they tracked right together. When we got to the later part of the growing season, we had a warmer September that had higher GDU accumulation. So we ended up the season 140 GDUs ahead of average in 2019. That helped our corn products that were late planted out just a little bit. And the freeze we had was the 10th of October. That's really right on average for what we see here at Gothenburg, and it was definitely a killing freeze this year when it came. When we looked at what happened in the field, we saw that actual GDUs required to reach mid-pollination ranged from 54 to 95 GDUs less than projected based on the information we had on the corn products. This indicated that the crop was on track to finish earlier than the GDU requirements indicated, similar to what we've seen in a lot of university studies. And that puts us on about 2 to 4 days ahead if you look at the average GDU accumulation at that point in the season. When we got to black layer, though, it was a little more variable. The 3 products that made it to black layer, the 76 RM product required 213 more GDUs to reach black layer. The 86 RM product required 62 more, and then the 96-day product finished up a little early and required 87 GDUs less than projected. And if we convert that to days, the 76 RM product took 13 days longer than we thought it would. The 86 RM product took 4 days longer than we thought it would. and the 96 RM product actually finished up 18 days sooner than we thought. And, that was a little bit of surprise to see that much variability in there. The other products in the study, the 101 through the 116, did not reach black layer. We just simply didn't have enough GDUs or time for them to get there. And when you look at where the corn products were throughout the growing season, I was doing checks periodically in the field to look at growth stage. The 10-9-19 check was basically the day before it froze, and the 101 was at 85% milk line, the 111 at 75, and then the 111 was at 50% milk line, and the 116 at 33% line. There's good data out of Wisconsin that shows that if you freeze hard at 50% milk line, you lose 12% of yield potential, and the losses go up if the freeze is even earlier than that. So we definitely froze those ones very early, and it cost us a lot, it looked like, in terms of yield. So in yield, the 76 RM product yielded about 80 bushels per acre. We got to physiological maturity, but because of the low yields, it's probably not very adapted to our area and wasn't a good choice to grow. The 86 through 106 RM products, we saw steadily increasing yields. And remember, the 101 and 106 RM products did not reach black layer, but their yields still kept increasing beyond the 86 and 96 RM products. And then you look at that drop off in yield for the 111 and the 116 because they froze long before physiological maturity. And when we look at grain moisture content at the end of the season, we harvested the 76 RM and 86 RM corn first. It was at low grain moisture content. The 96 and 106 we were able to harvest in early November, and they were at an acceptable moisture level. And then we had to wait a while for the 111 and the 116 to get down to a moisture content that we can shell. And in test weight is where you really saw the effect of that early frost and what it did, freezing the corn long before physiological maturity. The 76 RM product and even up to the 106 RM product had acceptable test weights, even though that 106 was only at about 75% milk line when it froze. But the 111 and the 116, which were not as far along, had test weights that went down to 50 bushels or 50 pounds per bushel and even lower than 50 pounds per bushel. And we did see that impact the grain quality. The 76 RM product, had excellent grain quality and high test weight. It reached black layer in plenty of time. The 106 RM product, now it was only at 75% milk line when it froze. So you see a little bit of tip shrinkage in some of the kernels. But overall, the test weight was still acceptable there. And then when you get to that 116 RM product, you really start to see the shrunken kernels causing low test weight, and then you start to see other quality issues like mold at some of the tips. Definitely going to cause a lot of quality discounts when you sell the grain, and it's going to be very hard to store. So our key learnings really were that the environment during the growing season really plays an important role in the actual response of a corn product to mid-pollination and black layer formation. The late planted corn for us appeared to require less than expected GDUs to reach mid-pollination. And unfortunately, due to the limited number of corn prods able to make it to black layer, for us it's difficult to determine, what the GDU requirement, whether it was more or less, for the products we had in this study to reach black layer in central Nebraska. Yield, harvest date, grain moisture content, and grain quality were all impacted by the product RM at the late planting date. However, one thing that we did see was that a failure to reach black layer did not necessarily make the RM a poor choice. It was interesting that the 106 RM product provided the highest yields in the trial and also acceptable grain quality, even though it only reached about 75% milk line at the date of the hard freeze. And the other thing it's important to remember is that these results occurred with slightly above average GDU accumulation with the planting date of June 17th and a near normal frost date. Changes in GDU accumulation and a change in the frost date could obviously dramatically change the outcome of these results. So it was an interesting study. It really did kind of provide confidence, and even at that June 17th date, it's still okay to go with that 106 RM product. So thank you for listening. We look forward to providing more agronomic information in the future, and I really hope that in the next couple weeks we can get those planters rolling safely. Thank you.